On the topic of Noah's Ark, one often has to ask, is the scenario presented in the biblical account plausible? It is my position that it is not, and although others have made videos mathematically debunking many aspects of it, I'm going to focus mainly on the water that falls. The water that falls on the ark is going to be heavy. It's going to have some weight because it has to cover the highest mountains. I want to see what force that water will be exerting on the ark, and what energy we need to counteract it, or if we even need to use energy at all. We now need to establish the height of Mount Everest, because that's the highest mountain, and we know that the water needs to cover the highest mountain in 40 days. So, one might think that since Mount Everest is currently 8,848 meters tall, that 8,848 meters of water would need to fall over the 40 days. Easy, right? Well, as creationists love to point out, Mount Everest is growing, and it will be shorter during the time of Noah's flood. So, using the current growth rate of 0.061 meters per year, we can see that at the time of Noah's flood, Mount Everest would have been about 8,604 meters tall, which is still a very high height. So, we need to have 8,604 meters of water falling over the period of 40 days, which works out to about 215.1 meters per day, or 0.149 meters per minute. Now what we need to establish is the dimensions of Noah's Ark, as given in the biblical account. So, if we look at the widths given, and then convert them to meters for easy use in our formula, what we find is that the length of Noah's Ark is 137.16 meters, the width is 22.86 meters, and the height is 13.716 meters. Since we only care about the water that's falling on Noah's Ark specifically, we can figure out the volume that's hitting every minute by using the height of the water that we'd already worked out, plus the width and length of Noah's Ark. This gives us water volume hitting the ark every minute of 467.186 cubic meters. Using the density of water, we can figure out that this weighs 467,186 kilograms. We can use this number to determine the force that's hitting the ark every minute. Now, since force is mass times acceleration, and we already know the mass of the falling water, we only need to know the acceleration. The acceleration of a falling object by gravity is 9.8 meters per second per second. So, to figure out the force that's hitting the ark every minute due to falling water, we need only to multiply our number of mass times 1.8. This gives us a figure of around 4 million newtons that are hitting the ark every minute, which is a lot. So, now how many newtons are hitting the ark total over the entire trip? Well, we simply need to multiply our number by 60 to get the number of newtons in an hour, then by 24 to get the number of newtons in a day, and then by 40 to get the number of newtons in the total trip. This gives us a figure of 263,717,107,200 newtons. Given the force that's hitting the ark total, we can now figure out the energy we need to counteract this force. Energy in joules is force in newtons times distance in meters. The distance we want in this case is the height of the ark, because we want to prevent any part of the ark from being crushed and the water is falling vertically. Since the ark's height is 13.716 meters, and we've already established the newtons in force, we can simply multiply this to get a figure of about 3.6 trillion joules needed to counteract the force. That's right, Noah needs 3.6 trillion joules to keep his ark intact on the trip. How much is that? Well, to give you a sense of scale, it's about a 20th of the energy that was released by the nuclear bomb detonated on Hiroshima. Needless to say, this is a lot. And I think we can all agree that Noah did not have a nuclear power plant on his ark. It's just another reason why this story is so implausible.